Albert Einstein, came up with the revolutionary theory, the theory of relativity. Einstein's mass energy relativity is a wonderful phenomena in the nuclear physics, modern physics. The theory explained that mass and energy are interconvertible to each other. A wonderful thing. Mass can be converted into energy, and the energy can be converted into mass. A wonderful thing. The mass can be converted into energy and vice versa. This new dimension to physics helped to resolve plenty of unsolved problems and formed a form for a lot of new theories. One among them is the existence of nuclear binding energy, thereby giving a clear insight into clear mass and internuclear interactions. That means that in the nucleus of an atom, many number of interactions taking place because of the binding energy. So, here if you observe the slide, Albert Einstein is responsible for the Einstein's mass energy relativity. In the nucleus, smaller mass, it is a smaller mass only. The nucleons like protons and neutrons are binding together with a sort of binding energy. Suppose a energy is predominant factor here. The nucleons are separated by means of binding energy. Suppose binding energy breaks. The binding energy, so nucleus plus binding energy, separated nucleons, that is smaller masses of nucleons, it may be a protons or it may be neutrons. Well, an atom comprises a nucleus at the center of the electrons revolving around it in orbital fashion. Nuclei constitute of protons and neutrons, combined called nucleons. Thus, we expect that mass of nucleus will be the same as some of the individual masses of neutrons and protons. But it is not true. The total mass of the nucleus is less than the sum of the individual masses of neutrons and protons, which in fact constitutes it. This difference in the mass is called mass defect. The difference in the mass is called mass defect, which is given by delta M is equal to Zmp plus A minus Z into M and N minus MnUc, where Zmp is the total mass of protons, A minus Z. A minus Z, Mn is the total mass of the neutrons, MnUc is the mass of nucleus. According to Einstein's theory of relativity, the mass energy is equivalent. That is, the mass of a system measures the total energy of the system, given by the famous equation E is equal to mc squared, where E is the energy, which is equivalent to the mass, m is the mass, and c squared, c is the c squared. That is the important thing. E is equal to mc squared, where E is the energy, m is the mass, and c is the current or speed of light. It is implied that the total energy of the nucleus is less than the sum of the energies of the individual protons and neutrons, which are together called nucleons. This implies that when the nucleus disintegrates into constituent nucleons, releasing some energy in the form of heat energy, which is an exothermic reaction. Liberating heat energy to the surrounding is called exothermic reaction. The energy emitted here is mathematically expressed using E is equal to delta M c squared. Now, imagine the situation of breaking the nucleus. To attain this, certain amount of energy is put into the system. The amount of energy required to achieve this is called nuclear binding energy. Thus, we can define nuclear binding energy as the minimum energy required to separate nucleons into constituent protons and neutrons, and is given by Eb is equal to delta mc squared. Thus, the difference in the mass converted into nuclear binding energy.